Hello everyone, we're back at it again with another lecture for AP Human Geography. Tonight we are continuing our discussion of population and moving into what is known as the epidemiological transition model. Now before we get started with the epidemiological transition model, I want you to go back and flip back through your notes to the demographic transition model. Particularly the portion where we look at the entire model itself, the visual, that has crude death rate, crude birth rate, natural increase rate, total population. I want you to review that real quick because we need to understand that in order to understand what we're going to be talking about tonight. So take a moment, flip back to those notes, take a look at that visual. And I want to draw your attention especially to the crude death rate because the epidemiological transition model is all about the differences in death rate. Notice that the death rate is different in every single stage of the demographic transition. In stage number 1, the death rate is high. It's high and fluctuating. Stage number 2, it declines rapidly. Stage number 3, it declines more slowly. Stage 4, it is low. And stage 5, depending on how we look at it, either the death rate starts to creep back up again or the birth rate declines to the point where the death rate is now above the crude birth rate, in which case more people are dying than are being born, the population is shrinking. So in each stage of the demographic transition, the cause of death is a little bit different. So on this slide, we have our definition for what the epidemiological transition model is, and here it is. Distinctive causes of death associated with each stage of the demographic transition. So as countries move through this, they're going to see distinctive causes of death at each stage. So that's going to be the important part that we really want to underline. So let's look at the model itself. The model was created by Abdel Omran, who was an epidemiologist in 1971. And that's one of those names that you're going to want to know. Very similar to some other names that we've talked about or will be talking about, like Thomas Malthus. You're going to want to know Abdel Omran. So put a star next to his name. Make sure that you know that he's associated with the ETM, the epidemiological transition model. So here's what we have. Stage number 1 is going to be characterized by infectious, parasitic deaths or diseases, accidents, animal attacks, basically anything that you can't really control. Notice that it was high and fluctuating in stage 1, the death rate was, and in stage 1, people can't really respond to those types of deaths. And that's why it's high and it's fluctuating, because there's not a whole lot of control with it. And a really good example of that was the bubonic plague, also known as the Black Plague. And so that's a good example to start us off with. Stage number 2 is referred to as the stage of receding pandemics. And we'll define pandemics a little bit later in the lecture. But for right now, know that as countries moved into stage 2 after the Industrial Revolution, we start to see better medical technology. And so we see advancements that allow people to respond to the death rate, which brings that death rate down. So that's where that receding comes in. It is starting to decline. But they're still fairly significant. That's why we have pandemics. Really good example of that is cholera. Stage number 3 is as far as Omran got with this. And he said that stage 3 was the stage of degenerative and human-created diseases. Now, to be clear what we mean when we say human-created, we're actually not talking about like warfare. We're not talking about like chemical weapons. We're not talking about things like that. Not that kind of human-created death. Instead, what we're talking about are deaths that are based on the accumulation of life choices that people make. So if people smoke their entire lives, well, that's going to have an impact on your life expectancy and the cause of death. If people are drinking alcohol their entire lives, that's going to have an effect. If you're eating, food that's not really great for you, that's going to have an effect on your life expectancy and things like that. And so that's what stage 3 was all about, is degenerative. Your body's starting to break down because you're getting older. And so that's what that one is. Now, stage 4 is where things change a little bit, because stage 4 wasn't originally part of what Omram created. This is actually added on by S.J. Olshansky and Brian Alt. Also names that you may want to know, but probably not as prominent with the ETM as Omram's name is. And stage 4, the operative word here is delayed degenerative diseases. And so they are delayed because, again, as countries become more industrialized, because they are more developed, we're seeing better medical technology. And so even some of the issues that we see in stage 3, things like cancer, there are medical treatments for that. And so people can live with those and go through treatments and survive longer. So they're delaying death a little bit longer as a result of medical advancements. And then finally, again, as we mentioned with the demographic transition model, this theoretical stage 5 that isn't actually part of the model, but we know is part of reality, is the reemergence of infectious and parasitic diseases. And the one thing that you need to know about this one is that some of those same diseases that we're seeing in stage 1 and stage 2 countries now are coming back to the very developed countries. And a really important reason as to why is space-time compression. So we're going to talk about that when we get to this particular slide tonight. So let's take a look at some examples here. We mentioned that the example of the stage 1 type of death or distinctive cause of death was the Black Death, the bubonic plague. And in this particular case, before we get started with the specifics of it, let's again ask our usual questions. First off, what type of map are we looking at here, and at what scale? And while there is no key, this is probably best labeled as a choropleth map, and hopefully you notice that this is at the national scale, even though the national boundaries don't exactly match up with what we see on the map today, because the bubonic plague happened centuries ago, hundreds of years ago. And it started in 1347. And this particular image looks at the progression of it during 1348. And during about a 5-year span, the numbers vary a little bit depending on what resource you're looking at, but somewhere in the neighborhood of 20 to 25 million people were killed as a result of the Black Death, of the bubonic plague. And that was somewhere in the neighborhood of 1/3 to 1/2 of Europe's total population, which is just mind-boggling. Half of an entire region's population was dead, and within a relatively small period of time, 5 years. I mean, this was something that was devastating. And to be clear, it wasn't just something that we saw in Europe. 13 million people in China were killed as a result of the Black Death, the bubonic plague. Now, here's the one of the interesting things about it. This was taking place in the 1300s. The germ itself wasn't discovered until the late 19th century. That is the late 1800s. And so that's, again, a product of the Industrial Revolution, because, again, those medical advancements, we're starting to realize what some of these things are. But people couldn't respond to this. People didn't know how to respond to this. And that was something that was devastating. Devastating. Next example of our ETM is cholera. And we have already seen this image before. This is Dr. John Snow's cholera map of London in the 1850s. So we asked this question before back in Unit 1, and we'll ask it again. What type of map are we looking at here? And hopefully you notice that this is a dot distribution map. I know that you have different sizes of symbols here, but again, keep in mind this is point data. The points, the dots, are specific because those are cholera victims. And so cholera is a great example of something that would be very characteristic of stage 2, because it was very much a product of, or something that we see in the landscape after the Industrial Revolution, because after the Industrial Revolution we saw much larger urban populations. We saw lots of people living very close proximity to one another, so higher density, higher concentration, and this is a big factor in what allowed cholera to spread so far as it did. And so that's another factor to keep in mind. Next example that we have up here is looking at cancer mortality rates, which is a really good example of something that you see in stages 3 and 4. Cancer and cardiovascular disease, so diseases related to the heart, are very, very much characteristic of stages 3 and 4 of the epidemiological transition model. The body starts to break down and we start to notice things. So in this case, we're looking at cancer. So let's ask, looking at these maps, what type of map are we looking at and at what scale? And we notice once again that this is a choropleth map, and hopefully you notice that the divisions are within the subnational units. So this is a county scale. All right. So a couple things that I want to point out for you. The map on the left is looking at cancer rates beginning in 1950. Now, in 1950, the life expectancy in the United States was 68.2 years. The map on the right is looking at cancer rates leading up to 1994. In 1994, the life expectancy in the United States was 75.7. Right? So that's a difference of about 7 years over the span of about 40 years leading up to that. And so it's important to note that with stages 3 and 4, with the degenerative and human-made diseases, that with the longer life expectancies, we're starting to see the choices that people make during their lifetimes begin to compound and can have a negative impact. Now, obviously, it's important to note that things like family history and genetics are going to play a role here as well. But, for example, if you eat McDonald's every single day for your entire life, could that potentially have an impact on your life expectancy? Sure it could. Just like if you smoke every day, if you drink every day, if you're doing those things, those choices begin to compound and your body is going to be impacted by that. Same if you work in a particular location. I mean, there's so many different things that over time our bodies begin to break down as a result. And that's what stages 3 and 4 are about, is our bodies, because we are living longer, starting to break down. And so we can look at that here in the United States. So these are the top 10 causes of death here in the United States. Now, it's important to note that the United States is an example of a country that is in stage 4 of the demographic transition. So birth rates and death rates are very low. Life expectancies are very high. And so if you notice this, number one cause of death in the United States is heart disease. Over 500,000 people a year die from heart disease. Next one is going to be cancer, again over 500,000. And then number 3 is going to be stroke, which is typically, again, I would say something that's typically associated with older people, right? Not always, but a lot of times. And that number drops down to under 150,000 people. So big gap between the top 2 and then number 3. But if you take a look at these top 10 causes of death, a lot of them have to do with longer life expectancies, people living longer, all right? The one that doesn't necessarily have to do with that, that's somewhere near the top, is the accident one. That comes in at number 5, accidents. But you'll notice that it says accidents not planned. And I've always kind of wondered what that means, because I don't know what a planned accident would be. But regardless, it is something that we are going to talk about here in just a couple of minutes, because it is the 5th leading cause of death here in the United States. But those numbers differ a little bit between men and women. So we're going to talk about that here in just a couple of minutes. The example for stage 5 that I would like to use is tuberculosis. Now that's the example that comes from our textbook, so let's run with it for a minute, but I'll give you another example that I want you to use as well. First off, let's ask, what type of map are we looking at? At what scale are we examining this? And we notice that it is a choropleth map, national scale. And the next question that I want to ask is, the number of tuberculosis deaths, does that reflect differences in levels of development? In other words, I don't want to say is it a good indicator of development, but are differences in levels of development evident on this map? And generally speaking, they are, because countries that are more developed aren't having the same amount of tuberculosis deaths as countries that are less developed. The areas where tuberculosis deaths are the highest are countries in generally sub-Saharan Africa. But the example that I would like to use more so for stage 5 is the relatively recent outbreak of Ebola in West Africa. Because Ebola actually came to the United States. There wasn't a huge number of cases, but part of the reason why it did is a product of space-time compression. The fact that people can get further faster now was a big reason why Ebola was able to make it to the United States. Because a doctor in West Africa boarded a plane bound back for the United States, and before he realized that he had Ebola, was already on that plane, was already back to the United States, and then interacting with people. And that's a big reason why. Now, if you go back a couple hundred years, when you don't have planes that are able to go across the Atlantic Ocean in a matter of hours, that doctor might not have made it to the United States in order to spread Ebola. And so part of the reason why stage 5 diseases are coming back to more developed countries or to core countries, part of the reason is because of space-time compression. That's one of the reasons. But that's a good example to see how it comes back together. One of the last big things that I want to talk about before we move on is just some of the terms that you might see associated with the diffusion of diseases, particularly on the AP exam. Now, this isn't something that is overtly part of this, but it's a good idea to at least know it and have heard it and have them in your notes. So please make sure that you add these. So we're going to run through them just real quick. If you hear something is endemic, it means that it's fairly localized. It's in a particular area. Whereas if you hear something is an epidemic, that's a much larger region. And then a pandemic, if you go back to stage 2, when they said receding pandemics, that was something that was fairly widespread. Okay, that's very big. At this point, if we said something was a pandemic, it would be an example like the Spanish flu during World War I. Something that was global, that multiple continents were affected by this. In addition to this, relatively recent addition to this, so please make sure that you have it, is the difference between vector and non-vector diseases. Vector diseases mean that there is something that is carrying the disease. There is like an intermediate that's carrying the disease. That's the vector. And malaria is a good example of a vector disease because malaria is carried by mosquitoes, which is the vector. The mosquitoes are the vector. So non-vector diseases mean there's not someone that's carrying the disease and spreading it to other people as an intermediate. Hey, it's from one person to another just through contact. All right. Good example of that is the flu. Influenza would be a good example of that. AIDS would be another example of a non-vector disease. Last thing that I want to mention today is looking at life expectancy and just mentioning the correlation here between the epidemiological transition model and life expectancy. Because life expectancy is shorter in stages 1 and 2, but it gets longer life expectancies in stages 3, 4, and 5. And so we notice that the causes of death change with that, because with shorter life expectancies, there's particular causes of death that lead to shorter lives. Accidents and animal attacks and pandemics and things like that lead to shorter life expectancies. But with longer life expectancies, there's actually different causes of death that come about because you're living longer. the body starts to break down in a way that it wouldn't when most people are younger. And the last thing that we need to mention with regards to this, and it's something that we'll talk more about in the next lecture when we look at population pyramids, is that when it comes to life expectancy, women tend to live longer than men. And there's a lot of different theories as to why. And so we'll go over. But I want you to kind of think about maybe why women might live longer than men. You know, try and brainstorm some reasons why you think that could be. I can't quite think of a reason. Is there anything that could possibly explain why women live longer than men? I'm not quite coming up with anything off the top of my head, or off the back of my friend there, as it were. So, I know I kind of included some ridiculous things, and fellas, I'm sorry. I had to. But there's actually some legitimate studies that have been done to try and theorize why women live longer than men, other than the ridiculous photos that I included here. So let me give you some actual material as to why women might live longer than men. So these are some of the theories. One theory suggests that female fetuses are actually stronger in utero. One of the studies suggests or says that there's actually 2.5 times more boys conceived than girls, but due to things like prenatal infections, the birth rate ends up being closer to 1-to-1. Another theory states that women actually develop heart disease later than do men. Another one suggests that social networks actually have a really big impact on people's life. This was a BYU study that actually found that people who had stronger social ties actually ended up living longer, and that they found women had stronger social ties than men. But they did note that there was one major exception. Married men actually had some stronger social ties, and as a result had longer life expectancies than single men. Another one suggests that women take care of themselves better than men. So here are some of the statistics from that study. Men are 24% less likely to have visited a doctor in the last year. Men are 22% more likely to skip things like cholesterol tests, and that 28% of men don't even have a regular doctor or a primary care physician that they visit. And then the final theory from this particular set of studies relates back to these photos, and that is that women are less likely to be daredevils. So some of the statistics that they cited there is that actually accidents are the third leading cause of death for men in the United States, whereas for women, it's the sixth leading cause of death. If you recall back a few slides, that it was actually overall the fifth leading cause of death in the U.S., but for men, it's third. And they actually looked at the psychology behind it, and they said that part of the reason that could explain this is that the frontal lobe of our brains, which is responsible for things like responsibility and calculating the risk of something, actually develops later in men than it does in women. And so the ability to effectively calculate risk takes longer for men than it does for women. So those are some of the studies that have been that have sought to try and examine why women live longer than men. And in our next lecture, we'll actually be able to spatially see that. We'll look at a way to examine things like life expectancy when we look at population pyramids. So that's all for tonight, folks, and I will see you next time.